Number one, two particles of masses 1.8 kilograms and 1.2 kilograms are connected by a light inextensible string that passes over a fixed smooth poly. The particles hang vertically. The system is released from rest. Find the magnitude of the accelerations of the particles and find the tensions in the string. We're going to find acceleration. Acceleration is A. We're going to find A and T, acceleration and tension. I would like to start with the assumption that we are going to assume that first the heavier mass, 1.8 kilograms, it goes down. Meanwhile, the lighter mass is 1.2 kilograms, it goes up. And then for T, okay, T is the tension, and the tension in the string, tension in the string, in the string. Okay, so the T is the tension. So according to the Newton's second law, that we can write it like this for the 1.8 kilograms mass, according to the Newton's second law, that ma times g minus t equal ma times a. And for 1.2 kg, it is mv, that's the gravitational force, T minus, T minus, this is, or T minus or minus T minus 1 equal mv times a. And I would like to calculate at, say, 0. So ma times g minus mv times g, ma a plus mb a. And I would like to factorize ma minus mb a times ma plus mb. Scroll down first. So G gravitational force is 9.8. Ma is 1.8 minus minus 1.6. I mean, 1.2, not 1.6. The result is 0.68 plus 1.2. And this is the result is 0.6. 0.6 times 9.8 is 5.88 equal, this is 3, equal 3a. So a equal 5.88 over 3. This is 1.96 meter per second square, or round off becomes 2 meter per second square. So this is acceleration. Now we're going to calculate the tension using this rule, this formula, T minus 1.2 times 9.8. 1.2 times 1.96. I use the second equation, that T minus mb times G, mb times A. So mb is 1.2, gravitational force 9.8, mb is 1, and A is 1 is now 1.96. Right, it's 1.96 A. So it's going to be T minus 11.76. You calculate this, 2.352. Then we can find T, 2.352 plus 11.76. The result is 14.112 or newtons, or 14.1 newtons. Question. Look at this diagram. A particle of mass 7.5 kg starting from rest at A, this point A, slides down an inclined plane AB. The point B is 12.5 meters vertically below the level of A, as shown in this diagram. Given that the plane is smooth, use an energy method to find the speed of the particle at B. Okay. So we are going to find speed or v, velocity. At point A, you can see at point A, the kinetic energy equals 0, because it starts from 0, and the potential energy is m times g times h. And at point B, this one, the kinetic energy is 1/2 mv squared, while the potential energy equals 0. Okay. So we can writing that m times g times h equal 1/2 mv squared. M divided by m equal 1, and it's going to be g times h equal 1/2 v squared, or v equals square root 2 times g times h. That one. So we can find velocity or speed 2 times 9.8 times 12.5, according to this information. So the result is square root 245. 15.65 247 on, or it's 15.65 meter per second. Next question, B. It is given instead that the plane is rough and the particle reaches B with a speed of 8 meters per second. The plane is 25 meters long, and the constant frictional force has magnitude Fn. Find the value of F. We will use the work energy principle. It means the initial potential energy equal the final kinetic energy plus work done. Okay, work done, of course, against friction. So it means mgh, this potential energy, and kinetic energy 1/2 mv squared, and work done F times S. M is 7.5, G 9.8, H 12.5. This is 1/2, 7.5, phi 8 squared, F times 25. So if you calculate this, 918.75, 240 plus 25F. So it means that 25F equal 918.75 minus 240. Okay, so 25F equals 678.75. Scroll down. So F equal 678.75 over 25. It is 27.15 newtons. Number 3, look this diagram. Coplanar forces of magnitude 52 newtons, 39 newtons, and Pn and P newtons act at a point in the direction shown in the diagram. The system is in equilibrium. Find the values of P and the values of theta. If you look at the diagram, I would like to create a triangle like this, triangle like this. Okay, this is 39, and this is P, and this angle is theta. So through this right angle triangle, we can state that cos theta equal 39 over P, or P equal, or P cos theta, P cos theta equal 39. And as well, another right angle triangle I can create for help us. This is 39, this is 52, and theta here, P here. So through this right angle triangle, we can state that sine theta equal 52 over P, or P sine theta 52, like this. So we can determine P through this right angle triangle. P equals square root of 39 squared, 52 squared. The root 4,225, it is 65. Now, please consult into this equation, this one and this one. And I would like to divide P sine theta over P cosine theta. So 52 over 39. So P divided by P equal 1. So it means sine divided by cosine equal tangent theta, 52 over 39. And we can determine theta equal arctangent, or tangent power minus 1 of 52 over 39. And the result is 53.13. So P is 65 and theta is 53.13. Next question, number 4. A bus travels between two stops, A and B. The bus starts from rest at A and accelerates at a constant rate of a meter per second squared until it reaches a speed of 16 meters per second. It then travels at this constant speed before decelerating at a constant rate of 0.75 a meter per second squared. Coming to rest at B, the total time for the journey is 240 seconds. Sketch the velocity time to graph for the bus journey from A to B. We're going to start from origin, here 0 to 0, and then if 16 meters per second here, based on this information, okay, the maximum speed, so it's going to be like this, the acceleration until 16 meters per second, and then constant, and it will be end at 240 here, okay, 0.240, and decelerates to 240, like that. So this is the trapezium. Find an expressions in terms of A for the length of time that the bus is traveling with constant speed. Right. So accelerations phase for the initial phase, or U, and this is for acceleration. For accelerations, U, or the initial speed, equal to 0, and then the final speed, or v, 16 meters per second, and the accelerations equal A according to information, and time to reach 41 or 16 meters per second. Okay, time to reach, sorry, no, T1, sorry. Meters per second that is speed, and time T1. So we can create the velocity U plus AT. So the velocity is 16 meters per second because U equals 0 plus A times T1. So we can find that, I'm going to write in here, that T1 based on this equation, that T1 equal 16 over A. And deceleration at deceleration, the initial speed is 16 meters per second, and the final speed, or v, equals 0 here, and the deceleration A equal deceleration 0.75 A according to the information, and the time T2. So the velocity equal U minus AT because deceleration. So it becomes 0 equal 16 minus 0.75 A, okay, T2. Okay, so you can state that T2 equal 16 over 0.75 A, or 4/3 times 16 over A, and 64 over 3A. So this is T1, this is T2. And the total time, we can determine the total time. The total time T1 plus T2 plus TC. TC is the constant speed. So I'm going to show you on this graph. This is the acceleration. And we got T1 here and T2 here. This is the decelerations, and this one is the constant speed here, TC. Right. The total is 240 according to the information. So this is 16 over A plus 64 over 3A plus TC equal 240. It's going to be TC equal 240 minus 16 over A plus 64 over 3A. This. Given that the distance from A to B is 3,000 meters, find the value of A. Okay. So if you look the graph, that is the trapezium graph, and I would like to find T, that the area under the curve equal 1/2 times 16, 240 plus T equal 3,000. Okay, and then it becomes 240 T equal, this is 8, 3,000 divided by 8. So T equal 375, because 3,000 divided by 8, 375 minus 240, and T equal 135. Now, T we can find also through 240 minus 64 over 3A plus 16 over A. Yeah, T. If you look on, you can evaluate on that graph, on the trapezium. So we can state this one. We can find 240, simplify this fraction, 54 over 3A times 3, 48 over 3A. And it's going to be 240 minus 112 over 3A of here. So it means T equal 240, okay, 340 minus 112 3A equal this one, because T 135, 5, right? And after that, minus 112 over 3A equal 135 minus 240. So minus 112 over 3A, it is becomes minus 105. Okay, right. So it means 3A equal, or yeah, 3A equal 112 over 105. So A equal, if you calculate 3 times 105, 112 over 315. And it is 16 over 45. Next question. Number 5. A particle A is projected vertically upwards from a point O with a speed of 80 meters per second. 1 second later, a second particle B with the same mass as A is projected vertically upward from O with a speed of 100 meters per second. At time t second after the first particle is projected, the two particles collide and coalesce to form a particle C. Our particle A and particle B collide and being particle C. Okay. So that T equals 3.5. I will start with the equation of particle A, displacement equations of particle A. The particle A, it starts at T equals 0 with the, it starts with T equals 0, and then the initial velocity, U, is initial velocity 80. So the displacement equation becomes 80t minus 1/2 gt squared. G is 9.8. So it's going to be 80t minus 4.9t squared because 1/2 times 9.8. And then the equation B for particle B. It starts at t equal 1 with the initial velocity 100. So at time t, B has been moving t minus 1 second. Okay. At time t, B moving. So it means the equations SB t equal 100 t minus 1 minus 1/2 g t minus 1 squared. It becomes 100t is 100 minus 1/2 4.9 because 1/2 times 9.8 t squared 2t plus 1 becomes 100t times 100 minus 4.9t squared 9.8t minus 4.9 because minus times plus. So the equation becomes minus 4.9t squared 109.8. It is plus 109.8t minus 100 minus 4.9. It is minus 104.9. Next, when A and B collide, so as A as AT equal SBT. So it means this and equal this one. Okay. 80t minus 4.9t squared, okay, equal this expression. Okay, so this expressions is expressions of this one as AT, and this expression is expression from this equation as BT. Okay, or 0. So becomes ATT minus 109.8T equal minus 104.9. And it's gonna be 29.8. Yeah, minus 29.8 T equal minus 104.9. So we can determine T. T equal, if you divide minus 104.9 over minus 29.8, the result is 3.5201 of 3.5. So this is the time. Question. Find the height above O at which the particles collide. Now use the particles A displacement. Particle A displacement is this one. Just now I have explained on part A, ATT minus 1/2 gt squared. So it becomes ATT times 3.5 because T equals 3.5. 1/2, 9.8, 3.5 squared. And if you calculate, the result is 219.975 or 219 point, 220, 220 as well. Yeah, because this one, yeah, 220 meters. I forgot just now, meters. This is meters. The unit is meters. Sorry, second. Sorry. Supposed to be the second. Yeah. Okay. So next one, meters. Find the time from A being projected until C returns to O. Just now, through the questions, we know that we have information that after collisions A and B, there is a new particle. The new particle that is the particle C. So the particle C is the made from particle A and particle B. Next, we're going to find the velocity each particle at collide. Particle A. Particle A, it launches at T equals 0. So the velocity formula, I will using this formula, the velocity equal initial velocity minus g times t. Okay, so it means VA velocity equal AT minus 9.8 times 3.5. It is 45.7 meter per second. Next, particle B. The particle B, it launches at t equal 1. So it has to move for 2.5 seconds. Why? Because 3.5 minus 1 equal 2.5. Okay. So it means 3b equal the initial velocity is 100 minus 9.8 times 2.5. 2.5. And it is 75.5 meters per second. So A already is 1, B already is 1. Let's continue. The next step, we're going to find the velocity particle C after collide. So velocity of particle C is P A plus PB by 2, so 45.7 plus 75.5 by 2, so 60.6 meters per second. And the next step, I'm going to find time for particle C when it falls from uh, the height 219.97. Just now we got this one. This one. I'm going to use this result. Okay. So when it fall from 219.97 meters to the ground, so it means the velocity becomes 0, and this is Vc minus gt. So this is time to reach the maximum height. How to calculate the time to reach the maximum height. So we can rearrange this equation becomes T equal Vc over G over gravitational force, or this is 60.6 according to this information over 9.8. And the result is 6.1367, or 6.184 second. And the next step, we need to find the maximum height. The maximum height is maximum 219.975 just now. 975 plus 60.6 over 2 times gravitational force. If you calculate, the result is 407.345 meters. This is the maximum height. And then the time to fall from the maximum height, from this height, 407.345, I'm gonna using this formula, S equal 1/2 times gt squared. Or we are going to rearrange this formula, becomes T. T equals square root 2s divided by gravitational force, or this is 2 times 407.345 over 9.8, and the result is 9.11764, or round off 9.12 second. And after that, we're going to calculate the total time. The total time equal 3.5 second, 6.184 second, 9.12 second equal 18.804. So this is the result. Next question, number 6. A particle of mass 1.2 kilograms is placed on a rough plane which is inclined at an angle theta to the horizontal, where sin theta equal 7 over 25. The particle is kept in equilibrium by a horizontal force of magnitude P Newton acting in a vertical plane containing a line of greater slope The coefficient of frictions between the particle and the plane is 0.15. So mu equals 0.15. The question, find the least possible value of P. The first step, I would like to find cosine theta. Based on this information that sine theta equals 20 or equals 7 over 25. So I will create the right angle triangle. This is theta, 7 here and 25 here. To find this side, you can using the Pythagoras rule that 25 squared, square root of 25 squared minus 7 squared. It is 625 minus 49. Square root 576 is equal 24. So this side is 24. So we can state that cosine theta equal 24 over 25. And the next step, we're going to find for all forces acting on this particle. Okay. The first, we are going to resolve perpendicular force to the plane. Perpendicular force. The perpendicular force acting to the plane was the component normal to the plane. That is weight equal mg cos theta. M is 1.2, and then the gravitational force I will using 10. You can using 9.8, but I will using 10. Approximately becomes 10 times cosine theta is 124 over 25, and it is 288 over 25. All right. On this diagram, I'm going to using the mg cosine theta. This particle, it means it has weight. This is m times g. Okay, m times g, it means 12 Newton. And this is mg cosine theta. And after that, the horizontal force P is component into the plane. And this is, I would like to sketch a straight line here. Okay. This is X. And if the right angle triangle like this, and this is theta. So this is theta. So X, this is P. It means sine theta equal X over P, or X equal P sine theta, like this. So the horizontal force P is this one, P sine theta. Okay, this force. And P sine theta, I would like to write in here, P sine theta is equal P times sine theta is 7 over 25. Or we can write in 7 over 25 P. That is horizontal force of P. So using the equilibrium, we can state that R equal 1.2 times 10 times 24 over 25 plus 7 over 25 P, or it is 288 over 25 plus 7 over 25 P. So this is mg cosine theta. This is P cosine, P sine theta. Next, we're going to resolve the parallel force. the parallel force acting to the plane. If you look on this diagram, you're going to find the weight component down the plane. It means mg sine theta, 2 downwards. This mg sine theta, okay. This side is mg sine theta. So, writing here, mg sine theta, and it is 1.2 times 10 sine theta, 7/25. So 12 times 7, 84/25. And after that, the horizontal force component up to the plane, okay, is to this one. This is P cosine theta. And P cosine theta equal P times 24/25, or 24/25 times P. So the equilibrium along the plane is F plus P times 24/25 equal 84/25. This is the first equation. This is from this one, mg sine theta. So this is P sine theta, and this is this one, mg sine theta. Right. Let's continue. So, I forgot for the diagram. Another force. So this is the R. Okay, R force here. So there are several force acting on the particle. Now, we're going to using the friction formula. The friction formula, F equal mu times R. Mu is 0.15 and R 288/25 plus 7/25P, and it equal 43.2 because 0.15 times 288, 1/25, and 0.15 times 7, 1.05/25P. And after that, substitute into this equation, this is F. So I would like to writing here F equal 43.2/25 plus 1.05/25P. Now, substitute this information into here. So this equation becomes 43.2/25 plus 1.05/25P plus 24/25P, 84/25. Now multiply by 25. It is 43.2 plus 1.05P plus 24P equal 84. Let's scroll down first. So it comes if this number plus this number, it is 25.05P equal if 84 minus 43.2, okay, and that is 40.8. So we can find P 48 40.8 over 25.05. Scroll down again, okay, and we have the solution 1.62874, almost 1.63. The solution is P. Next question. Number 7. A car has mass 1,200 kg and the car is traveling at a speed of 3 meters per second. There is a resistive force of magnitude kV Newton. The maximum power of the car's engine is 92.16 kilowatts. The car travels along a strike level road. Question. The car has a greatest possible constant speed of 48 meters per second. Show that K equal 40. 92.16 kilowatts is equal 9,216 watts. Right. Next, for these questions, all the engine power is used to overcome the resistive force. So I would like to write in P equal the resistive force times phi, and it equal this is K, okay, K time this is K phi, sorry, K phi times phi, and it equal K phi squared. Now substitute the values that P equal this number, so it's going to be 92,160 watts equal K times phi is, according to this information, 48 squared, and you can find K equal 92,160 over 48 squared, 2,304. It is 40. So it's proof. Right. Next question. At an instant when its speed is 45 meters per second, find the greatest possible accelerations of the car. The engine producing power is 92,160 watts. So the driving force at speed is F equal P over V. P is this one, this number, 92,160 watts over V, according to the information, is the velocity is this one, 45. If you calculate, the result is 2,048 meter, Newton, because F, unit of force, is Newton. Okay. And the resistive force formula is F resistive equal K times V, and it is 40 times 35. It is 1,800 newtons. So the car force, is F car equal total F minus F resistive. So it becomes 2,048 minus 1,800. It is 248 newtons. And after that, we're going to using the Newton's second law, to the Newton's second law, that A equal F car or car force divided by mass by M. So 248 newtons divided by 1,200, and it is 0.2666 on, round off becomes 0.267 meter per second squared. Acceleration for the unit is meter per second squared. And next question. The car now travels at a constant speed up a hill incline at an angle of arc sine or sine power minus 1, 0.15 to the horizontal. Find the greatest possible speed of the car going up the hill. All right. So the formula I would like to write in that F total or the total force equal 44 plus 40 mg sine theta, like that. This is not 44, this is 40 times this velocity. Yeah, this V is velocity, not volt, because this is not this question is about electricity. Right, let's continue. Now we're going to use a formula power equal F times V times speed, F times force times speed. So it's going to be P equal uh, V is 1, substitute 40 times velocity mg sine theta times v times this velocity. So if we substitute that power equal 92,160 watts, we can write in here 60 watts equal if 40 v times v, it is 40 v squared, okay, plus m is 1,200 times 9.8 times 0.15, because sine theta is 0.15 times 4. So this one, velocity v, right? And after that, it's going to be this one 92,160. This is 40 v squared. V is velocity, and if you calculate this part, that is 1,764 v. So it becomes the quadratic equations with v the variable. It's going to be 40 v squared plus 1,764 v minus 92,160 equals 0. And I would like to divide by 4. If you divide by 4, becomes 10 v squared plus 441 v minus 10,040 equal 0. So if you look this quadratic equation, A equal 10, B equal 431, and C equal minus 23,040. So phi we can find through this formula minus 441 plus minus square root 441 squared minus 4 times 10 times minus 23,040 over 2 times 10. And it is minus 441 41 plus minus square root 1,116,081. This 81 over 20. And it's going to be minus 441 plus minus 1,056.5 over 20. So I would like to using the solution is minus 441 plus, not minus. If minus, the result will be negative because there is no velocity negative, only positive. So minus 141 plus 1,056.5 over 20. And it is 615.5 over 20. And the result, 30.772. You may round off, becomes 30.8. Velocity, it means meter per second. The units. Next question. Number 8. This is number 8. A particle P moves in a straight line passing through a point O with velocity 4.2 meters per second. At time t second after P passes O, the acceleration a meter per second squared of P is given by A equals 0.6t minus 2.7. Find the distance P travels between the times at which it is at instantaneous rest. Since the acceleration is the derivative of velocity, we can write that the acceleration equal dv over dt. Derivative of velocity is acceleration. So it means the derivative of this, so the derivative of a function becomes 1. This is the acceleration, 0.6t minus 2.7. And then after that, we're going to find the velocity. We're going to find the velocity function. To find the velocity function is integral because it's the derivative, the integral of 0.6t minus 2.7 dt. And it is 0.3t squared minus 2.7t plus c. And after that, if our assumption that phi 0, that if t equals 0, the velocity is 4.2 according to this information. Okay. So if t equals 0, it means this is 0, this is 0 as well. So it's going to be 0.3 times 0 squared, minus 2.7 times 0, plus c equal 4.2. So c equal 4.2. So it means the velocity function, Vt, the velocity function is 0.3t squared, 2.7t plus 4.2. So if you look this equation, this expression, this is the quadratic expression. So now, when Vt equals 0, it means this equation becomes 0.3 squared minus 2.7t plus 4.2 equals 0. So it means A equals 0.3, B equal minus 2.7, and C equal 4.2. Through the quadratic equation formula, we can determine the value of t. So t, T1 and T2 equal minus becomes plus I would like to wait. I would like to divide first to simplify it. I'd like to simplify this divide. Divide by 0.3, and it becomes t squared minus t squared minus 9 if 2.7 divided by 0.9 t, plus 14 equals 0. So this is a equal 1, b equal minus 9, and t equal 14. So t1 and t2 equal 9 plus minus square root minus 9 squared minus 4 times 1 times 14, 2 times 1. 9 plus minus square root 81 minus 56 over 2. It is 9 plus minus square root 25 over 2. And it is 9 plus minus 5 over 2. So T1, 9 plus 5 over 2, it is 7, and T2 equal 9 minus 5 over 2 or 2. And after that, we're going to find the distance. Right. So the particle, through this information, we can state that the particle is at rest at t equals 7 seconds and at t equal 2 seconds. Now we're going to find the distance. To find the distance, we're going to using the integral from 2 to 7 of Vt function 0.3 t squared minus 2.7 t plus 4.2 dt. The first step, we need to find the integral of this expression. The integral is 0.1 t cubed minus 1.35 t squared plus 4.2 t. So this is the integral of this expression. And after that, substitute 7 and 2 into this expression. If you substitute, it's going to be like this, 0.1, 7 cubed minus 1.35, 7 squared, 4.2, 7 minus 0.1, 2 cubed minus 1.35, 2 squared plus 4.2 times 2. And if you calculate, it becomes 34.3 minus 66.15 plus 29.4 minus 0.8 minus 5.4 plus 8.4. And the result is minus 6.25. But distance never negative. So we can state that distance equal 6.25 meters.